150 Core Java into series part 2. Hi friends, we'll be covering 9 to 10 questions from Core Java. So let's start. We'll be covering what are wrapper classes, autoboxing and typecasting. What is string, string buffer and string builder. We'll also be covering some of the object-oriented programming basics like class, object, state and its behavior. So let's move to wrapper classes. The wrapper classes in Java provides the mechanism to convert primitive into object and object into primitives. When we create an object to a wrapper class, it contains a field, and in this field we can store primitive data types. These wrapper classes are basically wrappers around the basic primitive types. Wrapper classes can have null values. Primitive values cannot be null. Java collections only supports objects, primitive types and not objects. Wrapper classes can be used with collections to create objects from other types like string, integer num1 equal to new integer. We'll be passing 55 as a string. So here is a table that defines primitive type and their wrapper classes. Like boolean becomes boolean, char is a character, byte is a byte, short is a short, int is an integer, long is a long, float is a float and double is a double with capital D. Now let's discuss on ways of creating wrapper class instances. There are two ways of creating wrapper class instances using constructor and value of methods. So these constructors we will be reading in the next chapters. Using a wrapper class constructor, integer num equal to new integer 55. So we are passing 55 as an integer. In the next example, we are passing 55 as a string. And in the next, we are passing 55 as a double argument. And same 55.0f as a float argument. And then in the double quotes, 55.0f as a string. And then we are just passing a b as a character in character c1 equal to new character b. Boolean contains true and false. So boolean b equal to new boolean, we are passing true as an argument. So all the string values give true, anything else gives false. These all are some of the examples for creating wrapper classes using the constructor. So now we'll see how to create the wrapper classes by the second method. So another way of creating wrapper class instance is using value of static methods. Provide another way of creating a wrapper objects. Let's take an example. Integer 50 equal to integer dot value of 50. So 50 will be stored in a variable. Integer 8 equal to integer dot value of 1000 comma 2. So binary triple 1 is converted to 8. The value 2 is the base 2. We should prefer static value of method because it may save you memory, as when using constructor you will always create a new object, while using value of method it may return you cached value within a range. For example, the cached value of long is between -128 to +127. So wrapper objects are immutable. Once wrapper objects are created, you cannot change the objects. You can easily reuse the references to them. So immutable is the objects which can't change. So now let's cover the need of wrapper classes. Why do we need wrapper classes? There are certain needs for using the wrapper classes in Java. They convert primitive data types into objects. Objects are needed if we wish to modify the arguments passed into a method, because primitive types are passed by value. The classes in java.util package handles only objects, and hence wrapper classes help in this case also. Data structure in the collection framework such as array list and vector store only objects, references types and not primitive types. An object is needed to store synchronization in multi-threading. Now let's see advantages of wrapper classes. Collection allowed only object data. On object data we can call multiple methods, for example compare to, equals and toString method. Cloning process only objects. Object data allows null values. Serialization can allow only object data. So all of these are advantages of wrapper classes. These collections and cloning process and all how to create the object and serialization process will be covering in the next chapters. Now let's talk about autoboxing. Autoboxing is the automatic conversion that Java compiler makes between the primitive types and their corresponding object wrapper classes. For example, converting an int to integer or double to double and so on. If the conversion goes the other way, this is called unboxing. So opposite of autoboxing is unboxing. For example, integer 9 equal to 9. Integer 7 equal to new integer, we are passing 7 as an integer to the argument. 7 plus plus. That is also allowed in Java. Now let's see this example. Here we have a class autoboxing and we have a character A. So we are autoboxing the primitive to character object like character A equal to ch. Now we have an array list and we are adding 25 to the array list. So after printing array list.get0, we will be getting 25. So array list.get0. So this is a method to get the value from the array list. So this process is known as autoboxing. So above array list integer, array list equal to new array list integer. So that's the way of creating an array list in Java. So we'll be covering all of these into our coming lectures. Now what are the advantages of autoboxing? Autoboxing helps in saving memory by reusing already created wrapper objects. Autoboxing uses the static value of methods. However, wrapper classes created using new are not reused. Two wrapper objects created using new are not same objects. For example, integer 6a equal to new integer will be passing a 6 to an argument. Same integer 6b equal to new integer will be passing 6 as an argument. So now if we are comparing 6a equal to 6b, that is false. And if we are checking 6a dot equal 6b, that is true. So we'll be covering about this equals method as well. Now two wrapper objects created using boxing are same object like integer 6a equal to 6 and integer 6b equal to 6. When we are comparing this system.out.println, we are saying 6a equal to 6b, that is true, and 6a dot equal 6b, it is also true. So these are some of the advantages of autoboxing. So we'll be covering this equals method and this equal to methods into our coming lectures. Now let's discuss on unboxing. It's just the reverse process of autoboxing. Automatically converting an object to a wrapper class to its corresponding primitive type is known as unboxing. For example, conversion of integer to int, long to long, double to double, etc. That is wrapper to primitive. So here is an example. We have a class unboxing. Similar to autoboxing class, we are having a character ch equal to a. Now unboxing character object to a primitive conversion, char a equal to ch. So now we are converting that ch to char, that is unboxing. Ch was a object, right? It was an object type. Now we are trying to convert that object to our primitive conversion, that is known as unboxing. Let's take an example. We have an array list, right? In the array list we are adding 24. So now unboxing, because we get method return as integer object in num equal to array list.get0. So similarly we will be getting value 24. So we will be printing the value for the primitive data types. Here we are converting object to primitive type. So let's discuss on casting, that is type casting. Casting is used when we want to convert one data type to another. There are two types of casting, implicit casting and explicit casting. It is done by compiler. Example is automatic widening conversion, that is storing smaller values into larger variable types like int value equal to 100. So int num equal to value, that is implicit casting. Float f equal to 100, that is implicit casting. Now explicit casting, it is done through code. Example is narrowing conversion, storing larger values into smaller variable types. That is long num1 equal to 25987, int num2 equal to num1. Here we are typecasting num1 with int variable. So int x equal to 40.45. It will give compile time error. Int x equal to int 40.45. It is called explicit casting. So we are typecasting float variable into int. Now let's discuss on string. String is basically an object that represents sequence of char variables. An array of character works same as Java string. Just take an example. Char array ch, then brackets javat. So now string s equal to new string. We are passing ch as an argument. It is same as string s equal to javat. Now Java string class provides a lot of methods to perform operations on string such as compare, concat, equal, split, length, replace, compare to, intern, substring, etc. The java.lang.spring class implements serializable, comparable, and char sequence interfaces. We'll discuss about interfaces in the coming videos. Are all string immutable? Value of string object once created can't be modified. Any modification on string object creates a new object. All wrapper class instances are immutable too. Now string str equal to value 1, str.concat value 2, system.out.println. When we are trying to print string, what will it give? It will give us a value 1 only. So let's try string concat equal to string.concat value 2. So what will be the answer? When we are printing concat, it will give us value 1, value 2. In memory, string values stored in memory depends on how we create them. There are two ways of creating a string object, by string literal and by using new keywords. Now creating strings. First approach, by using string literals. Java string literal is created by using double quotes. For example, string s equal to welcome. This value will be stored in string constant pool inside heap memory. You can see that into the diagram. We have that welcome variable is stored into a heap memory. Each time you create a string literal, the JVM checks the string constant pool. So here in the constant pool, JVM will check if the string already exists in the pool. A reference to the pool's instance is returned. If the string doesn't return in the pool, a new string instance is created and placed in the pool. See here, S1 and S2 string. They both are equal to welcome, right? To make Java more memory efficient, because no new objects are created if it exists already in the string constant pool. Let's take the example. String s1 equal to welcome, string s2 equal to welcome. Now second string s2 equal to welcome, it will not create a new instance. In the above example, only one object will be created. Firstly, JVM will not find any string object with the value welcome in the string constant pool. That is why it will create a new object. Now the second way is by using new keyword. If new operator is to create string object, the new object is created on the heap. There will not be any reuse values. String s equal to new string and we are passing welcome as an argument. Creates two objects and one reference variable. In such cases, JVM will create a new string object in normal non-pool heap memory and the literal welcome will be placed in the string constant pool. The variable s will refer to the object in a heap non-pool. Now let's take an example below. Now in the below main method, we have string s1 equal to Java that will be creating string by Java using string literal. Now char ch array equal to strings as an array elements. Now string s2 equal to new string, we are passing ch to it, converting char array to string. Now string s3 equal to new string, we are passing example as an argument, that we are creating Java string by using new keyword. Now we are just printing s1, s2 and s3. Now let's discuss on string buffer and string builder. String buffer is a pair class of string that provides much of the functionality of strings. The string represents fixed length, immutable character sequences, while string buffer represents growable and writable character sequences. Syntax: string buffer s equal to new string buffer. We are passing just string junction as an argument to it. Okay. Now string builder in Java represents a mutable sequence of characters. Since the string class in Java creates an immutable sequence of characters, the string builder class provides an alternative to string class, as it creates a mutable sequence of characters. Now mutable is we can change the string. Okay. Now let's see the syntax. String builder str equal to new string builder, and we are just appending cfg to it. String dot append. We are just adding gfg string to the string builder. We have just seen the two ways of creating the strings using string buffer and string builder. So now using this string builder and string buffer, we can change the strings, right? Like earlier when we talked about string was immutable. Now after using this string buffer and string builder, the strings will be mutable now. We will be able to change the strings, whatever value we have provided to the string builder and string buffer. So now let's see. String buffer is a thread safe and string builder is not thread safe. So I can say string builder is faster. Now let's discuss on some of the differences between string buffer and string builder. And string is immutable. String buffer and builder are both mutable. Now string buffer is thread safe, string builder is not thread safe. String buffer is synchronized and string builder is not synchronized. So string buffer we got since Java 1.0 and string builder we got after Java 1.5. String buffer is slower and string builder has more performance. So string buffer is fast and consumes less memory when you concat strings. String is slow and consumes more memory when you concat too many strings, because every time it creates a new instance. So string buffer class is mutable, string class is immutable. So we can use each based on the situation or our need. Now let's cover some of the object-oriented basics, such as class, object, state and its behavior. Object-oriented programming concepts are as follows. We have class, object, method and method passing. Now the pillars of object-oriented programming are abstraction, encapsulation, inheritance, polymorphism. And polymorphism is of two types: compile time polymorphism and runtime polymorphism. So we'll discuss about class, objects and about all of these object-oriented programming concepts into our coming sessions. Java is object-oriented language because of its 6 pillars: class, object, encapsulation, inheritance, polymorphism and abstraction. Now let's discuss on class. Classes in Java. A Java class is a set of objects which shares common characteristic, behavior and common properties and attributes. There are certain points about Java classes are mentioned below. Class is not a real world entity. It is just a template or blueprint or prototype from which objects are created. Class does not occupy memory. It defines state and behavior that an object exhibits. Class is group of variables of different data types and group of methods. A class in Java can contain data member, methods, constructor, nested class, interface, etc. We'll discuss about all of these data member, method, constructor, nested class and inheritance in our coming sessions. So here we have just given an example. You can see we have an ID, int ID, string name. Both of these are data members, and we have a static method, public static void main, that is used to run the class. So down in that class we are just creating the object of a student class. Student s1 equal to new student, and then we are just printing s1.id and s1.name. So we are using new keyword to create the object of a class, that is a student class that we have taken in the above example. So we'll be just printing s1.id and s1.name. That id and name are the data members that we have provided in the student class. So now let's discuss on the object. What is a Java object? An object is an instance of a class. It is a basic unit of object-oriented programming and represents real-life entities. A typical Java program creates many objects, which, as you know, interact by invoking methods. State of an object might change with time. An object consists of state, behavior, and identity. State. It is represented by attributes of an object. It also reflects the properties of an object. Behavior. It is represented by the methods of an object. Now identity. It gives a unique name to an object and enables one object to interact with other objects. Now let's talk about class and objects in the real time. Map of a building is a class and the building itself is an object. Now let's talk about superclass of all Java classes. Superclass of every class in Java, it is object. Every class in Java is a subclass of object. When we create a class, we inherit all the methods and properties of object class. Like let's take an example, string str equal to development. Now let's try to print string str dot toString, method inherited from object class. Now dot toString dot string dot hashcode and string dot clone. So all the methods, these are inherited from the object class. Now if we just try to check a condition, if string instance of object, and it will print I extend object. So now it is clear that superclass of all the classes in the Java is object. Thank you. And now in our next video we'll be covering 9 to 10 more questions. Thank you. Like and subscribe.